Good day everyone, I'm Gillene Labonete and I'm here to present to you plastic eating worms. There are tons of plastic waste generated each year and only a small percentage of it gets recycled. The other large portion of the waste present a lot of challenges from water contamination to animal poisoning. Polystyrene, a cheap material made from styrene, accounts for 7.1% of the total plastic consumption in US alone. It is mostly used for short-time or one-time usage. However, it is durable and resistant to biodegradation. And so, because of the large difference between its service time and biodegradation time, it has accumulated in a lot of areas. There have been earlier research on worms which can biodegrade polyethylene, the polymer which makes up most of the plastic films available commercially. Polystyrene was thought to be non-biodegradable until recently when Wei Min Wu and his colleagues from Stanford found out that the larvae of the Tenebrio molitor or darkling beetle can chew and eat styrofoam. In their study, 3 batches of styrofoam-eating worms at 25 degrees Celsius, 80% relative humidity, and 16:8 light-dark photoperiod were studied. There are 500 worms for each batch, and most worms survive for 1 month, after which they stop eating to become pupae and eventually beetles. Results imply that the styrofoam diet did not have any negative effect on the survival capabilities of the mealworms. Styrofoam was degraded with a retention time of 24 hours in the larval gut. Fecal analysis showed that the styrofoam was depolymerized. Within 16 days of trial, 47.7% of ingested styrofoam was converted to carbon dioxide and the residue was converted as piccola, which makes out about 49.2%, and the biomass, which makes up about 0.5%. Droppings can be used in soil for crops, and mealworms with styrofoam diet are as healthy as mealworms with normal diet. The degradation process is as follows. Styrofoam is chewed into small fragments which increases its contact surface area with the microbes and enzymes once it becomes ingested. The gut microbiota excretes enzymes which catalyzes the polymerization of the polystyrene fragments, and the products are further degraded into carbon dioxide by a number of microbes and even mealworm hosts. Other products are further taken in as biomass. The rest are ingested as piccola. This research is significant because it has the potential of solving global plastic pollution problem, because now there is finally a way to degrade polystyrene as it was thought to have been non-biodegradable. This can also start a search for marine equivalent which can help in reducing the amount of plastic waste in our oceans. Finally, this research can also potentially be the start of engineering powerful enzymes for plastic biodegradation once the mechanism for biodegradation is fully understood. This particular patent discloses how polystyrene is fed to the yellow mealworms. Polystyrene is basically mixed with bran, a byproduct of milling grains, with a ratio of 1:20. This new discovery is significant in the Philippine setting because it is expected that the forest dump sites for the waste from Metro Manila can only accommodate garbage for the next 4 decades. And so if we can find a way to reduce the waste we generate, and then it will be helpful. Also, it can help reduce marine waste, fish kills, solve flood problems due to crash clogging, and reduce health risks. Here is a list of my references. Thank you for listening.